Welcome to the first in our lecture series honoring Vicky Funk and all the contributions to our field. And there were so many contributions. Rosemary Gillespie and Robert Whittaker actually summarized these recently. And I can just actually highlight them for you. She was one of the founding members of our society and our first female president. And she took a major role in steering our society towards having a culture of informal exchange in ideas and welcoming the stance of our students. She really was an early pioneer in a field in applying phylogenetics within historical biogeography. She was deeply knowledgeable. She was passionate, especially obviously about her favorite taxon, the daisy family, but so many other things too. She was a pioneer in our field, someone who could always straddle the contentious divide between philosophies and biogeography. And please take my word for it, when we started out, there were many contentious debates across our society. Her book, Hawaiian Biogeography, co-authored with Wagner, this became a seminal contribution to the field of historical biogeography. And she fittingly won a number of awards, including the Azagray Lifetime Award, the Stebbins Medal, and the Linnaeans Medal. She was really an inspirational model for all of us, especially for young female scientists. And she did that. She made these great contributions to our field at the same time with self-deprecating. She had the capacity to get along with so many people, especially we should remember for her kindness and her encouragement, and she was fearless in her approach to our science. So again, I thank the Society for giving me the honor of providing this first lecture, Vicky Funk, and all the contributions. The title of my talk then is There Is a There, the history and the frontiers of the geography of life. So I'll try to paint a very broad picture of our science, its development, and its importance and its promise for the future. And we are standing on the shoulders of some very tall people who came before it. And it really is a privilege for me to learn from them and try to build, however modestly, from the foundations they established. And one of the most influential people, really in most sciences, especially in the natural sciences, was Alexander von Humboldt. His idea that nature was connected in all different ways, Natur gemalde, was an inspiration for all scientists of the day. He saw this grand tapestry of nature, how the air and the water and the soil and the plants and the animals and the volcanic activity of the earth and the storms and the activities and influence of people, how all this was tied together in this grand tapestry. And the tapestry woven through this, the tapestry, and what held it together was the geography of nature. And his writings, his narratives of his explorations, and his approach, the holistic approach to nature, were things that inspired the young scientists of those days, including young Charles Darwin and Alfred Russel Wallace. Now, there are many other luminaries in our field, that some of which are my favorites, but were pretty much unappreciated during their lifetime, at least in terms of how they should have been recognized by their peers. So this includes William Smith, whose map of the geological strata of England was really the map that changed the world, because it tied together the evolution of the Earth's rocks across space and time. Alfred Lothar Wegener, of course, took that to another level when he developed the first comprehensive theory of, well, continental drift, but also the beginnings of plate tectonics theory. He wasn't appreciated till long after his death. And actually, one of the key sets of insights that finally convinced scientists that the plates were as dynamic as Wegener postulated was Marie Tharp, a woman in the 40s and 50s. She actually wasn't even allowed to go out in the field and collect information, in this case, bathymetric information from soundings that hundreds of different ships were taking across the oceans, including the Atlantic. So she was actually locked in the lab, but she was tediously tying together and analyzing all that information, and finally realized that what was missing from Wegener's theory was that the oceanic crust was dynamic. It was opening up in particular places, and she was the one who identified the in this case, mid-Atlantic ridges as the places where new oceanic crust was forming. She actually showed it to an administrator who cast it off as, I'm sorry, just being girl talk, but soon afterwards, a man came along who also found that the mid-oceanic rifts were also the sites of earthquake activity. And then the administrator was finally convinced, and again, that wasn't really until the 50s, early 60s, that we finally realized plate tectonics was real, and we had to include it as part of the history of place to understand the history of species. So these stories here are terribly informative in that they tell us not just how science progresses, but sometimes why it stalls, and the challenges we have to get over to actually make these revolutionary insights across our fields. Why weren't they accepted? Well, William Smith, he was from the wrong social class and the wrong economic class. Alfred Lothar Wegener. Wegener was from a country that was relatively unpopular during World War I and right afterwards. And also, he was outside the field of geology. He was a meteorologist, of all things. And Rhea Tharp was a woman in a time when the contributions of women were not appreciated. Now, there are really other luminaries in the geography of nature, including some of them that were providing their transformative insights when I was a young scientist trying to find out what this thing called biogeography was. And Robert MacArthur and E.O. Wilson, individually, they revolutionized their fields, but also collectively. And they showed how we could advance science through collaborations. Dan Simoloff collaborated with many other people, as well as Jared Diamond, and all of these made contributions to ecology, community ecology especially, but also to the field of biogeography, and especially, at least most influential in terms of the few contributions I've been able to make, have been James Hemphill Brown. And he again also saw the holistic, the ties between nature and how we could advance our understanding of the world using that holistic approach, and especially when we place things in a geographic context. And so the distinctiveness of place is really the central observation of biogeography, the central theme that ties all these disparate studies together. And this really didn't come to fruition, or this wasn't really understood until we expanded our knowledge. And so we have a lot of gratitude that we should express to the explorers, especially the European explorers of the 15, 16, 1700s. They expanded our knowledge from that of relatively local understanding of the natural world to regional, and finally to a global understanding of how nature varies from place to place. And once we did, and once we started to compare biotas across the world, we realized that they were different. Its distinctiveness of place challenged the existing prevailing doctrines of the world. And it was Buffon who pointed out that different regions, even those with similar environmental conditions, were inhabited by different assemblages of species. That's Buffon's law. And to explain the distinctiveness of place, he, and eventually others, especially Darwin and Wallace, had to develop a theory of how the world, and especially how species, evolved. And so again, the distinctiveness of place is the central, and this is why it's really the most transformative insight in really all of the natural sciences. It was transformative to Darwin. He realized on his oceanic voyages, and especially comparing the biotas from island to island across the Galapagos, that each island was its own evolutionary arena. Wallace took that again to another level. Not only did he and Darwin independently develop the theory of evolution via natural selection, but by comparing the biota across Indonesia and Malaysia, and then across the world, he developed this global understanding and was able to develop this classical visualization of the evolutionary arenas of the world. They both realized that what we study now was transformative. That grand subject, as Darwin said in a letter to Joseph Dalton Hooker, that almost keystone of the laws of creation, geographical distributions. Well, from this then we eventually developed what I call the mantra of biogeography. In the 70s, again, when I was a grad student, Theodosius Dobzhansky wrote that nothing in biology makes sense except in light of evolution. Well, no one takes argument with that. And we realized, again, as we looked at the natural world and how it varies from place to place, that this thing called evolution occurs across space as well as over time. And so the mantra of biogeography is that many, if not most, of the compelling kaleidoscope of patterns in biological diversity, they make little sense unless placed in an explicit geographic context. Well, then what about this statement? What of this statement? There is no there. It's used all too often, but I guess many of you know where it comes from. Gertrude Stein wrote that, the American novelist, and she wrote it when she was talking about her hometown of Oakland, California. And she wrote and described it as a land of rain and wind, of hunting, of cows and dogs and horses, of chopping wood, of making hay, of dreaming, of lying in a hollow, all warm in the sun, shining, the sun shining while the wind was howling. You can imagine, you could feel, you could sense that, you could even smell that. But when she visited her hometown again, it had undergone urbanization, and it had become like any other town. It had lost its distinctiveness of place. And so she closed this passage with the lament that, what was the use of my having come from Oakland? There is no there. Well, we're also seeing this loss, this waning of the distinctiveness of place, and the waning menagerie of species that Darwin and Wallace and others discovered for us and described for us. In fact, obviously, maybe it's not going to be a surprise to you folks, but they saw what was happening to nature, even back at their time in the 1800s. And so Darwin wrote, it is impossible to reflect on the changed state of the American continent without astonishment. Formerly, it must have swarmed with great monsters, but now we find mere pygmies compared with the antecedent allied races. He was writing about the discoveries of megafauna throughout the world that were and occurred and roamed those lands in recent times, but were now gone from those places. And Wallace later on wrote essentially the same thing, or about the same waning of the menagerie of life. We live in a zoologically impoverished world from which all of the hugest and fiercest and strangest forms have recently disappeared. Well, over time, again, we realize the importance of conserving these species, and also the value, the potential value of applying the principles of biogeography to conserving endangered species. And of course, foremost among all of those who helped establish the field of conservation biology was E.O. Wilson. And in a preface to a book on Alfred Russel Wallace, he actually tied together biogeography and conservation as well as anybody could. And he described it as this: the vastness of the tropical archipelagos also provided the knowledge that Wallace needed to conceive the biological discipline of biogeography, which has expanded during the late 20th century into a cornerstone of conservation biology. Within just a few years after that, Larry Nahidi and I put together a volume, and in it we actually articulated this new synthesis of the fields we call conservation biogeography. And basically it's the application of the lessons from the theory and from the patterns of biogeography for conserving biological diversity. And it argues that success in conserving biological diversity really depends upon two lines of research. First of all, addressing the Wallacean shortfall. And this is the gap in our knowledge of the geographic distributions and the extinction of extinction forces. So what we're really saying is, even though we've got these long lists of species, for very few of them, we actually have a good picture of what their geographic range is, and especially what it was. And also, we know that these are threatened by many different types of extinction forces. Well, we need to be able to predict, not only know where those extinction forces are today, but predict how they will expand across landscapes and across seascapes. And then the second line of research that's essential for us to have some success in conserving the true character of nature is we need to conserve the distributions of species. In so doing, then, we conserve the geographic, the ecological, and the evolutionary context of nature. Well, I still have to take this a bit step further with maybe a too melodramatic description here, an epitaph on the distinctiveness of place and the homogenization of nature. Now, that term is actually something introduced to us by Julie Lockwood and Michael McKinney in the late 1990s. And what we're really saying is the very character, that signal of nature, the distinctiveness of life, the distinctiveness of place is now waning, and we're losing the opportunity to make these transformative insights as others have, because places are becoming similar. We're finding the same suite of species as we move from one place to another place, even the most isolated places across the globe. And that waning, the distinctiveness of place, is really a function or being caused by two things. One of which is the extinction of endemic species, those very things that define that place and distinguished it from all other places. And at the same time, we're introducing a redundant set of species to these isolated places. The rats and cats and dogs and house sparrows, the things that we have to carry with us and for some reason naturalize that place to be more like our own places. And in fact, it's this latter thing, the introduction of species, that's also exacerbating the problem by driving endemics to extinction. And again, Darwin realized that this would happen. When he wrote, I think this is remarking of a Galapagos hawk, he was able to approach it and push it off a branch with the butt of his gun. What havoc the introduction of any new beast of prey must cause in a country before the instincts of the Aborigines have become adapted to the stranger's craft of power. Well, I could, but I really shouldn't end on such a dark note. And there really is great reason for optimism. There still is a there. Sometimes that is something that's being discovered from the clues and the mysteries of the past. And we have these wonderful scientists and illustrators such as Mauricio Antone, who is showing us what ancient assemblages look like. And when I say ancient, actually, what I really mean is just before man arrived to these places, Australia, North America, South America, etc., they were dominated by these huge megafaunal creatures of mammals and birds and reptiles that strongly influence all of the ecological communities that occurred in those places. We also have some wonderful science and historians and again artists again who are able to reconstruct the dynamics of, dynamics of extinction forces. In this case, the extinction force is us. But again, a fascinating story is that we are still learning about the geographic dynamics of our own species and, of course, how that influences other species across the globe. This latter is just one in a series of illustrations which are accompanied by long narratives by the Hawaiian hermit Koanui. So again, there is still a there out there. We have some wonderful people, paleobiologists, who are, again, unlocking the mysteries of the past. I've had the pleasure of working with one of those, Sandra Vandergeer. And she's one of the people who are discovering these creatures, these bizarre forms of life, including dwarf elephants. I don't know if you could read this, but this thing was just under 90 centimeters, under a meter high at the shoulders. Uh, in addition to those dwarfed elephants and other dwarfed proboscideans and hippos, etc., some of the isolated islands across the globe were also inhabited by creatures such as this, little things getting huge. And this is a giant, actually. This is the relative of essentially shrews and moon rats, Dinogalarix from the Mediterranean islands, and this one was almost a meter long. It increased compared to its ancestor by 200-fold, 200 times the mass of its ancestor, and some of these elephants decreased in mass to just 2% of the mass of their ancestors. And again, there was a menagerie of these creatures across islands in many parts of the globe. Well, in doing a global survey, Sandra found that the patterns, not just in diversity per se, but the patterns in diversity, this pattern that many people studied and described as the closest thing to a rule in ecology, the species-area relationship may have been very different than the pattern we are describing as natural today. This black line here is the paleo-insular and really the pre-human pattern across the globe, looking at numbers of species of mammals, terrestrial mammals on these islands as a function of their area. But as you see, if you look at these a little closer, the blue dots indicate the drop in diversity once we lost the endemic species. So here we're looking just at the extant native species on these islands. But of course, we've done more than that. We've introduced, again, a redundant suite of species across these islands, and really the overall diversity, mammalian diversity on these islands is much greater than, it probably takes a different shape than the natural paleo-insular pattern. But again, it's important to realize what we've done. So we've reduced endemicity and we've reduced the distinctiveness of these insular biotas, because as we go from one place to another, we still see that random set of species. And at a global scale, of course, we've reduced global diversity because we've not just decreased the numbers of species, but we've lost the most distinctive species, the hugest and the fiercest and the strangest life forms that Wallace was talking about. Now, we have many other terribly creative people, and in this case, Soren Fabry and Hans Christian Svenning, who have used sophisticated GIS and advanced techniques and spatial statistics to give us a global view of what the world was like in patterns in diversity, in other characteristics across the globe. This one focusing on megafaunal species and how their diversity and distribution looks today and how different it is than actually the natural pre-human pattern across the globe. So there is a there. Our paleo people are discovering and redescribing it for us, so we have a better picture of the natural patterns of nature and how nature varies across the globe. Maybe even most inspiring is the discovery of species across the world in little recesses of different continents and oceanic basins. And the numbers are somewhere like 100+ species are being discovered every year in many different groups, insects and mammals and fish and plants and so many other organisms. This is to the point at which, if you look at mammals, are a group that you think are extremely well studied. They're relatively big, easy to detect. But we're still discovering new species of mammals at a rate of somewhere between 10 and 25 species per year. This pygmy three-toed sloth and the dolphin and these two mammals, the pied bat and the striped rabbit, look like something my kid marked up with his magic marker, and primates and ungulates. You get at the rate of 10 to 25 species per year. So there really is still they're waiting to be discovered and waiting to be described. And again, we've got some extremely creative people who are using advanced techniques to put this together and develop really a target for us to better focus our limited time, energy, and funds to those places where we are most likely to discover species. This is from Schipper and his colleagues' work on geographic patterns of mammals across the globe, and these are hotspots of newly discovered species. So these are the places that we should, if we want to find these species before they're lost, we should focus our limited energies and time. So again, there is still a there. And one way to discover that and to provide even more important contributions to conserving biological diversity is to temper our studies with at least a note of humility. And again, many scientists are doing that. Joaquin Hortal, Straub, and their colleagues have put together these wonderful maps of ignorance, showing in this case really dark blue are those sites with very few or that are very different from well-sampled sites. And again, this helps us better target our limited energies and funding to those places that are most likely to provide the information necessary to conserve species before they're lost. So how do we advance our study? How do we advance the geography of life and conserve these marvels of nature? Understanding this and preserving also the biological distinctiveness of the world depends upon a few things. First of all, addressing the Wallachian shortfall, and also the approach we take. We should adopt and advance von Humboldt's holistic approach, not to Grimaldi. And we should follow the lead of distinguished scientists, especially Vicky Funk and James H. Brown and their colleagues, in making these contributions through understanding this is a challenging and holistic field. We have to tie it together through integration. And as smart as these people are, no one person can do this all. So we need to collaborate. We need to be and use collegiality to do this, and still at the same time creativity as individuals and especially creativity as groups. To blend this all, to tame this all with humility, to hold our egos down, and yet still at the same time be fearless. Fearless in our approach, fearless in knowing that if we're going to do something that's really special and hasn't been done before, quite often we're going to be wrong. But we still have to push on, and again, these are the ingredients in contributing and in many cases providing those transformative insights, in this case for how life varies across the globe. Now, in closing, I could talk about the importance of our field, but I can't do it any better than Dennis McCarthy did in his wonderful book, Here Be Dragons. And in it, he says, biogeography, once a secret delicacy enjoyed only by geniuses, now must be elevated from its current obscurity and placed alongside literature and history as indispensable components of a truly enlightened education. So I thank McCarthy for saying that. I also thank the Society for inviting me to give this talk, and especially in joining them, paying tribute in this homage to Vicky Funk and all her contributions to our society and to our science in general. Thanks.